Hey, welcome to Math Made Easy. Today we're taking on a very important world problem. We have Miley Cyrus who's looking to do a bit of twerking. So the parameters of the problem here are that Miley has 20 feet of fencing. She wants to put up a three-sided fence against a wall to maximize her area to twerk safely. So we have two width sides. We're going to have a length side to this fence, and what we're going to have to do is maximize the area inside. So a couple things we're going to have to keep in mind. One is the formula for area. We know that area is equal to length times width. It's a box. Multiply width times length, you're going to get the area inside. So we have to keep that in mind. And then the other thing we have to do is set up the problem so that we have length in terms of width. How do we do that? We know from the problem that Miley's only got 20 feet of fencing to work with. So we know that the total perimeter of her fence is going to be 20 feet. And we know that that is two widths plus a length. So we can write, rearranging, we can rearrange this as length is equal to 20 minus 2 widths. That's going to be important. So now we can express the perimeter of the fence solely in terms of widths as length as 20 minus 2 widths instead of length. So now if we go back to our formula for area, we can write area as width times our new length, 20 minus 2 widths, which we said is equivalent. And we can multiply this through. As 2w, 20w minus 2w squared. And so now we have a formula for area completely in terms of one variable, width, and if you notice, it looks an awful lot like a parabola. What can we tell from this equation? Well, we know there's a negative in front of the squared term, so we know that the parabola is going to open down, which means we'll get a maximum point to this parabola. If you recall graphs of parabolas, if there's a negative in front of the squared term, you end up with the opening down parabola, which means we can solve for a maximum A. This is the equation of A, this parabola. So what we want to do is try and figure out what this maximum point is for A. So if A is equal to 2w, did it again, 20w minus 2w squared, there's several ways you could solve this, but assuming only high school knowledge, no derivatives for optimization, we're going to have to solve this as if we were trying to figure out what the vertex of this parabola was. And for that we need to put this parabola into vertex form, which involves something known as completing the square. So we're going to take this term and we're going to rearrange it a bit. So we have that is equal to negative 2, and we're going to factor the negative 2 out to start. So we'll say negative 2, so this term becomes w squared from right here, and then this other term, if you factor out the negative 2, so divided by negative 2, you're left with a negative 10 in there. So that you could multiply this negative 2 back through the brackets and arrive right back where we started. Now what we want to do is complete the square on this inside term. Now that we have this w squared term by itself, we can complete the square on the inside term. And if you remember the steps for that, we know we have to take this this inner piece that's in front of the W term, and we divide that by 2 and square it. So 10 divided by 2 is equal to 5. Squared is equal to 25. So what we're going to do is add and subtract this 25. We're sort of cheating by adding and subtracting it, so really we're not changing the equation. So if we write this again, we're writing it as negative 2 w squared minus 10w. We're going to add a 25, and then we're going to subtract off that same 25. So the equation doesn't change, these cancel each other out, but we're going to move this one out of the brackets so that it's equal to negative 2 w squared minus 10w plus 25. And to move this out, we have to consider this negative 2 factor in front, and so we multiply that by negative 2 to get a positive 50. Negative 2 times negative 25 is positive 50. Okay, so we've got this new formula where we've completed the square, and the great thing about completing the square, hence the name, is that this is actually a square. So if you remember factoring polynomials, you're looking for a number that's going to square to equal, two numbers that will multiply to equal this value and add to equal this value. Well, if you take negative 5 and negative 5, negative 5 times negative 5 is going to equal this 25, positive, and negative 5 plus negative 5 is this negative 10. So we can write this as negative 2 w minus 5 squared plus 50. And we've just arrived at what is known as the vertex form for a parabola. So what we can see from this is that the height of the vertex is going to be 50, and the x-coordinate, so we know it's going to be 50 here, and we know the x-coordinate from this is going to occur when this is equal to 0, so w is equal to 5. So the coordinates of this are actually 5, 50. You can read that right off of this vertex form. That's why we've done it this way. It's easy to get that information. So we know because it's negative, it opens down, so we know that we can solve for the vertex, and that will be the maximum point of the area. So we've just solved that a equal to 50 is the maximum that we can get, and that occurs when w is equal to 5. So what does this mean? Well, this means that when Miley's building her fence, she needs her width to be 5, and if she puts 5 on either side here, we know from the perimeter formula that 20 minus 2w leaves us with length, or 20 is equal to 2 widths plus a length, so we subtract off 2 times 5 is 10, we're left with the length equal to 10. And we've just solved for the dimensions that Miley has to build her fence to give her the optimum amount of area inside for twerking.